Hey guys, welcome to your notes from Unit 5, Lesson 6. Today we'll be talking about families of linear graphs. We've been talking about lines and different ways to graph them, and now we're going to look at ways that they are all connected, how they are in fact related to make a family. By the end of the day, you will be able to explore the effects of changing both the slope and the y-intercept of linear functions. So let's compare these lines right here. We have three graphs, one representing a cheetah's speed, another the elephant, and finally a third with the spider. So as you're looking at these graphs, you can notice that a cheetah covers more distance in the same amount of time as an elephant or a spider. This means that the cheetah runs faster. Let's go this way. It runs faster than the elephant does. You can also tell that the graph of the cheetah's speed is a lot steeper than the graph of the elephant or the spider. The y-intercept is the same, but the slope is different. Their y-intercept on this graph is all at 0, but their slopes are different. The cheetah has the biggest slope because it's the steepest, and then the elephant, and then the spider. Okay. So this is called a family of graphs. So a family of graphs is a group of graphs that share something in common. They have at least one characteristic in common, and that characteristic will set them apart, will make them different from another group of graphs. For example, if we look at these graphs, you'll see that they move in the same way. They have the same slope. So we'll write that down. This is a family because they have the same slope. You'll also notice that they're parallel. All lines with the same slope are parallel. They never intersect. So they're all increasing at the same rate. These guys are related not because they have the same slope. They have different slopes, but they have the same y-intercept right here. They are both +2. They both intersect the y-axis at 2. So they have the same y-intercept. These guys, however, are not related. They don't have the same y-intercept. Here our green guy has at 1.5, 3 halves. The other one is at 0. Their slopes are different. Our slope is 7 halves. Our other slope is 1. So they're just not related. I mean, they can be friends still, but they're not related. By the way, friendly numbers is a real thing in math. So that's fun. Okay, so let's look at some graphs. I'm going to graph them for you. Let's start with 4x plus 1. This tells us that our y-intercept is 1, so I'm going to put that at 1, and that our slope is 4. So we go up 4 over 1 to make our second point, and there we have our first graph. There it is. Excellent. Next one has a different y-intercept at -3, but it has the same slope, up 4 over 1. So we connect those 2 points, and if we did this correctly, they should run about parallel. So that's very exciting. So their y-intercepts are different. They're at 1, they're at -3, but their slopes are the same. So they are a family of graphs because they have the same slope. If you want to play with some other graphs that have that same slope, just use your finger tool up here, tap on Graph A, and that'll open a graphing simulator for you right here in Safari. So you notice we have our first graph, y equals 4x plus 1, which is this purple guy. Our green guy is y equals 4x minus 3, which is the same. And then this guy has y equals 4x plus any number a. And you can change that graph, and no matter what your y-intercept is, the slope is always the same. So as you change the y-intercept, the graph moves up and down. It shifts up and it shifts down. We'll come back to that later. Let's look at our second graph. Here we're going to graph y equals x minus 2. So go down 2, and then our slope is 1. So go up 1 over 1, up 1 over 1, up 1 over 1, woo! And connect them all. Our other graph has, minus 2 again. But this time our slope is 1/5. So we go up 1 over 5. That's our second graph. So connect these guys. Excellent. So our intercepts this time are the same. They're at -2. Our slopes, however, are different. Sorry, our slope is not 1, our slope is not x, our slope was 1, so our slopes were 1 and 1/5. So this is considered a family of graphs because they have the same y-intercept. So if you, again, take this little hand tool, you tap on graph B, you can check out that on this graph we have our first one, x minus 2, and then our second one, 1/5 x minus 2. All these graphs have the same y-intercept, but as you change the slope, either as our slope gets bigger, it gets more steeper, or as our graph gets smaller, as our slope gets smaller, it gets less steep until it's negative, then it starts to get real steep again. So that's super fun. Alrighty. Now, that's great, but when are we going to use this in real life? Well, if you want to get some tunes going, again, tap on the car wash. It'll open up some theme music for you. But we have our friends Eric and Chris who are starting their own car wash business. Eric wants to charge $15 per hour. This is going to be slope. But Chris says, hey, I want to charge $12 per hour. So X is going to represent the number of hours that we work. So Eric says he's going to charge $15 an hour. That means we're going to say Y equals 15x, because he earns $15 for every hour he works. Chris says, you know what? I'm going to compete with you. I'm going to go for a discount. And he is going to charge $12 an hour. So in graphing each equation, we just mean the slope is 15. So after 1 hour, Eric charges 15, which is going to be here. After 2 hours is 30, 45, 60, etc. Chris, on the other hand, is only charging $12 an hour. So after 1 hour, he's got 12, 2 is 24, 3 is 36, 4 is 48, and 5 is going to be 60. I ended at 5 here because it's right on the tens, so it'll make a nice graph. Excellent. Oh, we didn't label our graph. X is our profit. That's our earning. No, just kidding. Just kidding. That was Y. X is hours worked. Okay. So comparing and contrasting the graphs of the equations. Well, let's look at what they have the same and how they are different. They're the same because they're both linear. They're both lines. They also have the same y-intercept. They both intersect the y-axis at 0. So that's the same y-intercept. They also happen to have the same x-intercept, which is at 0 as well. The thing that's different is slopes. Since Eric is charging more, his line is steeper. So these are the same family because they have the same y-intercept. Yay! Cool. So we're talking about families. Let's do one more term when we're talking about families. We'll talk about the parent graph. So the parent graph is the main squeeze, the main guy. It's the simplest. It's the one that comes first. It's the simplest of all the graphs in the family. It's the most basic. For example, if you look at y equals x, y equals x is the most basic in this family because first of all, let's look at why it has a family. This is a family because they have the same y-intercept, which is 0. They all intersect at y equals 0. But they're different because they have different slopes. But since this one is the most basic, it has a slope of 1. This allows us to see what happens as the graph changes. As we saw earlier with our demonstration, as we change the graph to be steeper, or rather, as our graph gets bigger, as our slope gets bigger, the graph gets steeper. And as our graph gets smaller, the line gets flatter, less steep. Is that a word? It is now. So when you're working with a positive slope, as m increases, as your slope increases, the line is steeper. However, if you're working with a negative slope, notice as we decrease, I'll go back to this situation. If we're working with negative slope, as the slope gets even smaller, then the line gets steeper. So if you have negative slope, the more negative it is, the steeper it is. But as you approach 0, it gets flat. And then as it gets negative again, it gets super steep. So if your slope is negative, as the value of m decreases, your line is getting steeper again. And then finally, let's go over to our family here with the same slope, but a different y-intercept every time. This one is the most basic because its y-intercept is 0. But you'll notice as we change our y-intercept, our lines move up and down. So as b increases, the line shifts up on the y-axis. This is another way to help us graph. Instead of just starting at the y-intercept every time, we can just take an original graph and just shift it up. So here we've got this line. I'm going to highlight it in this pinkish because it's already this pinkish color. Y equals 1/2 x plus 5. We want to change this graph. First, we're going to change it so it has the same slope but shifts down 1 unit. Remember to shift down, that's changing the y-intercept. So we want to make our y-intercept be 1 less. So we're going to take this guy and we're going to move him down 1. I guess we'll make him blue. Why not? Okay. So in order to do that, we're going to take our original equation, y equals 1/2 x plus 5. Y equals 1/2 x plus 5. We're going to keep our slope the same, but our y-intercept needs to subtract 1. So we need to take this minus 1. That was hard to see. I will rewrite it. Minus 1. So that gives us y equals 1/2 x plus 4. And now let's check real quick. Does that match the graph that we have? Do we begin at 4? We do. Do we still go up 1 over 2, up 1 over 2? We do. Excellent. So we did that. Okay, let's do it again. This time we want to keep, so we had the same slope. This time we're going to keep the y-intercept the same, but we want a gentler positive slope. So we want the slope to be not as steep. In order to make our slope not as steep, oh, I made that the wrong color. So our slope needs to go smaller. Needs to decrease. Let's take our original equation again, y equals 1/2 x plus 5. And as a visual, we're going to take our original line and we want it to go just not as steep. It needs to be more like that. So let's make it purple. Why not? Okay. So to make our slope smaller, we need to think of something smaller than 1/2. How about 1/4, I guess? So we just make it smaller, 1/4. I'm gonna rewrite that. Y equals 1/4 x plus 5. We're keeping our y-intercept the same, and we're only changing our slope. So let's see if our graph matches our equation. Are we still at our y-intercept of 5? We are. Is our slope at 1/4? Oh, it's not. We need to go up 1/4. Where's 4? Here. 1/4 like that. So we need to adjust him a little bit that way. There we go. And finally, we need to have a steeper negative slope. We're going to take our original, or I did it again. We're going to take our original equation, and we're going to keep the y-intercept the same. So we're not changing our b, but we are going to change our m, a steeper negative slope. So first, we need to make it negative. There we go. It's negative. But to be steeper, it needs to be a bigger number. So what's something bigger than 1/2? A number that's bigger than 1/2. I already kind of used red. Orange. How about 5? Well, our y-intercept is 5. So how about 4? 4, excellent. So we need to, in order to be steeper, okay, so gentler means smaller. Steeper means higher. Excellent. Okay, so we'll rewrite this whole guy as y equals negative 4x plus 5. And now let's graph that guy. We still have our y-intercept at 5, but we go down 4, 4 over 1 here, leaving us with this. I said leaving us with this, there it goes, line right here. A much steeper line. And there we did it. We adjusted these new graphs. So here you go. Here's a new way to graph. Instead of just making an XY table, you can just describe shifts of the same family. Keep these shortcuts in mind. Keep these shortcuts in mind, and have a fantastic time on your homework.